Good morning, student. In the last class, I have discussed the magnetic field produced by a moving point source. In this class, I am going to discuss about the magnetic field due to a current element. Magnetic field due to a current element. Now, what is a current element? Suppose this is a conducting wire. If it is carrying a current I, and if we take a small portion of the wire, say dl, so this element is known as a current element. Okay, and it has a length dl, and how much current it is carrying, I. Okay, so we are basically going to determine the magnetic field due to this current element. Okay, so to calculate the magnetic field due to a current element, we have to use the superposition principle. This superposition principle is applicable for electric field as well as for simple harmonic motion also. It's a very powerful theorem in whole of physics, and according to the superposition principle, the total magnetic field B caused by several moving charges is equal to the vector sum of each magnetic field B is vector sum of each magnetic field due to individual charge. Okay, individual charge. Okay, this is the superposition principle in this case. A superposition principle can be stated in different way depending on the condition. Here the condition is that the total magnetic field caused by several moving charges is equal to the vector sum of magnetic field due to individual charge. For example, this is current I. So this current I is due to the drift of the electron. I have already told you in the last classes also, the drift of the electron, there will be a current I. So the magnetic field for each charge there will be an individual magnetic field, and therefore in order to find the magnetic field due to the current element, we have to sum up basically all the magnetic field due to each individual charges. Okay, so let me draw this plot again in a slight better way. Suppose this is a conducting wire, a part of the conducting wire, so we are telling it as a current element. Okay, so suppose this is a conducting wire, this is the area of cross section, and this is the length of the wire. Okay, so this is area A. Okay, and this is length dl. Okay, the length of the current element we have taken it as dl. Okay, so if there is a current through this current element, the current will be carried by the free charges, that is the electron. Okay, so let's assume there are small n number of electrons per unit volume of the wire. Okay? Per unit volume there will be n number of free electrons are there. Okay, and when the free electron move with a drift velocity Vd, then there will be a current through the element. Okay, all the electron move with a average velocity Vd, and it will constitute the current. Okay, so now what is the volume of this current element? Its area is A and its length is dl. Therefore, volume of the current element is how much? Current element is equal to A into dl. Okay, so how much electron this volume element will carry? Because you see, per unit volume there are n number of free electron. What is the volume of the current element? AdL. Therefore, AdL volume will contain how much electron? We have to multiply n with AdL. Okay, therefore number of free electron free electrons moving. Each electron move with a velocity Vd. Vd here is the drip velocity. I have discussed about the drip velocity in the previous classes also, and during your class of current electricity, you are going to obtain the expression of Vd. For the time being, just assume that each electron move with a average velocity, which value is equal to Vd. Okay, so number of free electron each moving with velocity Vd is equal to how much? We have to just multiply n with this number, n a into dl. Okay, this is the total number of free electron moving with a drip velocity Vd. Okay, so how much total charge? Because each electron will carry a charge small q, and total how much number of electron? Na dl. Okay, therefore total number of charge that is flowing with the current, total number of charge flowing will be equal to, we have to just multiply it with q. Okay, so this is the total number of charge that is flowing through this current element. Okay, and each